Good evening. I'm Jeffy Jacob, and welcome to GW Prime Live. Today, we have with us Dr. Y. Nityanandan, who's a professor and the head of the Takshashila Institution's Geospatial Program. He's working on several themes in defense and national security and possesses a doctorate in urban spatial informatics and has 14 years of research and academic experience in geoinformatics. His research interests include advanced remote sensing, image processing, GIS analytics, urban and ocean informatics, and importantly, geointelligence. Welcome, sir.
Hi, good evening, and thanks for the invite. It's my pleasure to be on your show today.
Thank you. So,
Yeah,
India's space program began as a civilian program first, unlike other countries where the space programs started for defense needs. How is Indian military integrating the space capabilities in their program? And what do you think are the innovations that can be brought to the table?
I think it is the requirement was such in the Indian context. As you said, the other other programs were started as it's largely as a military activity and then turned out to be an application with civilians. Whereas in our case, it is more of started as in civilian application. um, you know it is largely focused on mapping our resources and for especially for monitoring land and ocean at large. If you take an example, the first set of satellites, the IRS-1A and 1B, which was launched in 1988 and 91, eventually worked until 92 and 2001 respectively. They are primarily used for mapping land use, land cover, agriculture, forestry, hydrology, soil classification, coastal wetland. Look at all of this. It's an application of natural resources, right? Or disaster management, or a bit of extension of cartographic work like mapping infrastructure of the parts of the country and so on. So we all focused on application of geospatial technology. Indeed, till 1996, we never had a satellite which looks out at different scientific things, at least in the information that we have in open domain. And we had something called IRS-P3, which was first sent for technology evaluation and scientific methodological studies in 1996. So you can see almost close to a decade after the satellites which were launched in the first go. So we were not focusing much on the technology aspect. We're focusing more on the application of it. It is quite understandable. That is what is required for the nation for those times, and that is what we are largely focused on it. When it comes to contrastingly, when it comes to other space program, let's take one space program. If we talk about the American satellites, so the American satellites, from 1958, their first satellite was to study Van Allen radiation belts of our charged particle trapped by the Earth magnetic field. And thereafter they have a satellite called Pioneers, which studied about exploring interplanetary space and investigation on solar winds. And then there's a satellite called Trio, which was launched in 1960, which was looking at cloud formations from space. It is largely for weather forecasting. And there's a satellite called Corona, which was launched in 1960, and then the subsequent things till 1972, which was something used for defense technologies at large. It is critical for intelligence during the Cold War by capturing detailed image of Soviet Union and other regions. And then they have Transit in 1960, which looked at navigation system for the US. So these are all different satellite systems or different satellites. Those are launched by US in early days. Look at these. These are actually for different scientific applications. They might have been useful for the application as well, the civilian application as well. But then either it was largely classified for scientific purpose or for the defense technology to start with. So it is a matter of pursuing core scientific research and utilizing it for civilian application versus starting with a civilian application to begin with in order to put the nation's requirement at first.
Need of interoperability between the Army, Navy, Air Force, and space organizations. How can India as a country develop an effective space doctrine or strategy?
I'm sure effort must be made to see the overall utilization of the space-based resources as applications, especially in the downstream aspect of application. If you look at it, in that includes optimizing requirements through defense challenges. Whatever we are seeing as a defense challenges, we need to have that interoperability between the services and space organizations. So the challenges that we put out for each of the services, for say, should have a common thought, and ideally the facility should be in sharing the data from one services to other, as well. So if you look at it, especially when we are moving towards something called a theater command kind of system, where there is a necessity to work together and to share resources among each other, especially when we do not have much of finances and specific budget for catering each of the needs. So there is a necessity to work along together and to share resources which are built for specific applications. And the electromagnetic spectrum, specifically when you design a satellite on a particular spectrum, is for Earth observation or for reconnaissance and so on, it is a necessary to utilize it for multiple applications. It's not just one service is raising a requirement for a particular satellite, works on a specific aspect of electromagnetic spectrum. It can also be used by others. So it is more like one could use the spectrum to study vegetation change on land. Similarly, the other service could see it utilization on the water. So what I'm trying to say is, it's more like what we call in research, for few people in remote sensing research, for some people, the cloud information available on satellite images is an error, because largely we depend on the cloud free data sets. We are quite interested to use cloud free data sets if you are using optical imagery, whereas for those information became an input data for a scientist who is working on cloud physics of it. So for some people, the cloud became a data. For some people, cloud became a error. So similarly, if we have a satellite, when we figure out its requirement together, when we figure out its applications together, there is a lot of things that we can do it. As I said, especially when you are moving towards a theater command, the monitoring and mapping of sea, land, and water, I think it is not just belongs to one service, especially when it comes to geospatial service. There's an integration of all to be done.
Very true, sir. There is an integration for all the three military forces. What role, sir, can India's private sector play in advancing the military space program and boosting the nation's space capabilities?
I think there's no doubt they're fantastically doing something big and unique, where the entire globe is looking at us these days. But I personally feel we are largely focusing on increasing our numbers in terms of remote sensing capabilities, the number of satellites. We are more interested towards building constellations, and we are more interested in bidding, competing each other and providing service to people and so on. But that the amount of research and development which is put out on the sensor aspect, which largely help us to think of something, a satellite which can get a different information where other satellites can bring in. So that is something I think it is weak at the moment, and we are largely working on comfortable things. We are buying or making sensors where the physics is fairly established, and then we are putting out in orbit in big numbers, because that kind of business model, I believe, which is quite successful. But then it also has an incentive from government when you can able to launch and get data at a required level. Then there is a business model exists for that. But there is less time and money people want to devote for R&D, because in this aspect you can bring something new, but we are not sure about this the opportunity for doing business out there. So we need to do more innovation. We need to push to new areas on space-based applications, especially technology which can be dual use. Because building a technology only for military or civilian application may not be a good business model for space business, especially which is risky. So people has to think beyond what is available and need to do something different, where a satellite can bring a complete different perspective than what we know so far. And then for those kind of initiatives, definitely government agencies and other different services, especially, need to extend their interest and encourage such bold and experimental projects. Then there's a slight gap. We need to shift our gears towards that, and it will definitely put us in a very interesting space.
Very true. We are seeing very rapid advancements in frontier technologies like AI, machine learning, real-time satellite imagery. In what way has these emerging tech impact national security?
Yeah, the technology is growing insane, right? We need to catch up with the speed at the development happens across the globe, and not just India. It's not about a development of AI with one particular country. Globally, there are different things happening. So the technology must be used effectively in order to improve our efforts and increase our preparedness, surveillance, and counter reactions against possible threats. In my opinion, for effective utilization, we need to clearly understand the technology and apply it at right time at correct and for correct application, because it is becoming a trend. Like, everybody wants AI and ML application in all the products, that is, or all the solution that is given to them. And it is believed that AI and ML could be a solution for it. But then people who actually works on it knows the complexity associated with it, the kind of data to be required for training, and so on. Right? I'm not getting into the details of it, but then what I'm trying to say here is there are certain problems where a simple digital image processing and a classical numerical modeling techniques may provide a necessary output as people expect. But then people request for AI and ML in most of the solution, because that becomes a fancy selling term for people. And people also wraps it by saying, oh, we use AI and ML in the software. Then the software gets a new dimension as the whole world is moving towards it. So we need to use it appropriately, and especially from the security point of view, we need to identify whether this kind of things are required, or the solution which is without using AI and ML would be good enough. So we need to come to that stage, and we need to be more aware of our adversaries, of course, how they are using, what they are using, what are the different ways in which they are using it, and how better we can use it. That's more important with this term, because when we are looking at the gaps and the developments happening on the other side of the part, we should also remember there are interest in looking at what is actually happening on our side as well, right? So we need to fill our gaps. At the same time, we need to actually wide open in understanding the development of technology from multiple perspectives across the globe.
Speaking of technology, how can geospatial technologies in this case be effectively integrated into existing military and intelligence frameworks to understand these national security risks?
Yeah. So it's I believe it's a tricky question, because a lot of people see geospatial, let's say, and space as separate component, and a lot of people feel like geospatial is just about maps and mapping, but it is very different, right? So if I ask a question, is everyone in the national security domain aware of geospatial technology like they are guessing about AI and ML? I would say no. We need to sensitize the need to build the capacity with different agencies, first of all, right? Because geospatial technology is seen as I said, it is seen as a tool for making maps. That's how the kind of utilization in services, to a larger extent, either it has been for a high resolution image interpretation, or with few people and few agencies working on different tools and technologies to make inference out of the information. But then largely people feel like, okay, this is something a new technology that is good, but how can I make use of it? Will this be useful to you? Because that kind of capacity, the understanding or appreciating the geospatial data is limited, or it is a border security force. We need to build a basic knowledge on GIS. Perhaps people can able to appreciate it, and they will figure out more new applications that we are not aware of so far. So in fact, this tool can reduce the workflow and the money that we are spending at present. So these kind of things comes once the understanding of the technology and appreciation of that comes in the national security framework, where you will use it, how intelligence, how geospatial intelligence can be used for the regular work. That is something once they realize, once they appreciate, it will be largely used. Second, let us understand, the opportunity for defense personnel to learn this broad spectrum of geospatial technology in our country is, I feel it is limited, as the more considerable teaching in traditional setups still focus on, as I said, image processing or the basics of mapping and cartography, or the utilization of the technology for a very niche component. People will not get a chance to look at its overall physics and overall science of it in order to think something beyond what has exist with their current system. So it is necessary to impart the basic knowledge with young officers who can contribute to the development of field. I would say more, importantly, on algorithms, building moderns which are suitable for the services. You don't have to build something for the society. Perhaps you can build something for your own application, which later on can be tweaked for civilian application. So but then the geospatial, it is not just an interest of army, but it is an interest of navy and air force also, because a lot of people say, oh, geospatial, the army is the best people because they would be using more. But what I see is possibly an application more or equally available with air force and navy, but the type of application is different, right? One can think about mapping resources and assets when it more sounds like an application of army, but the navy can potentially use it for underwater maritime domain awareness, or even for marine spatial planning. I'm very happy that at least a lot of people within our circle these days are also working on marine spatial planning. A lot of young researchers are coming up and showing interest on working on it. So that's a good thing. So all we need to have is geospatial technology. Or what we need to have in geospatial technology is basically thinking spatially. Otherwise, people feel, oh, it's a technology with a lot of data and computing facility, we don't need it. So at least people in armed forces can think of, or people at CAPFs and others can think of utilizing this technology at their own level. All you need is just an interest. With a standalone computer, you can actually do it well. And people can, once it happens, people can appreciate the open source information available on geospatial sector as well.
Okay, sir. So thinking spatially is something which we have to do. So regarding capacity building, since we have the geospatial policy, where are we?
Well, we have a geospatial policy that is good for civilian space. We need to build capacity at different levels. Even it is envisaged in geospatial policy to build capacity with larger quantum of people. It is not just preparing people for becoming a geospatial analyst or scientist. We need more people to work at different levels. Let's say surveyors, people who can fly drones, people who can work on very minor component of geospatial technology. So I feel there is a lot of opportunity in civilian domain also. There will be more and more small training institutes and institutions which are focused on building short-term capacity with people, because that is a need for an hour. In addition to the existing university-based teaching framework, we also need a specific kind of interest, or the institution should train the defense and national security spectrum, because we need to work more to make people appreciate, as I said earlier, it's the utilization and effectiveness of the data. At least in civilian space, we have something called a geospatial policy, right? Whereas we don't have that in the defense spectrum. We don't know how it will formally bind, or enforce people to look into it, possibly, which can help their, help to improve their productiveness. But then I doubt it is. There's no, formal framework exists there. The interest is to be driven by respective security or the institutions which are related to its own training people, or let's say each of the services and its own training institutes are someone who should consider this kind of courses in order to build a basic idea. Once you have a basic idea, then people can actually build more on it.
Thank you, sir. Thank you for taking time out of your busy schedule for giving us some wonderful insights on Indian defense space. Thank you.
Thank you so much. Have a good evening.
Hello and welcome to GW Bulletin, your daily dose of geospatial news. I'm Sachin Awana and here are the latest happenings. NASA has selected three proposals for concept studies of missions to investigate the complex system of space weather that surrounds our planet and how it's connected to Earth's atmosphere. The three concepts propose how to enact the dynamic mission, which was recommended by the 2013 Decadal Survey for Solar and Space Physics. The dynamic mission is designed to study how changes in Earth's lower atmosphere influence our planet's upper atmosphere, where space weather alike auroras and satellite disruptions are manifested. This knowledge will benefit humanity by helping us understand how space weather can interfere with crucial technology like navigation system and satellites. The dynamic mission is designed to make measurements within Earth's upper atmosphere between 50 to 125 miles in altitude. With multiple spacecraft, dynamic simultaneous observations from different locations can give scientists a more complete picture of how waves propagate upwards through this part of the atmosphere. The 14th edition of Indo Pacific Geointelligence Forum 2024, hosted by Geospatial World, concluded with a focus on the need to safeguard countries in the region. The insightful fora discussed global commons, shared threats, maritime risks, looming space warfare, and how geospatial tech helps disentangle complexities in a strategically crucial region. The two-day event witnessed an outpour of army officials, government personnel, private industry people, and academia, amongst others. Geospatial experts and influential people shed light on the combined power of geospatial intelligence, space based assets, and cutting edge innovation to tackle emerging threats in Indo Pacific, which is the fastest growing region of the world as well as a critical avenue of global trade and commerce. Thales, Spire Global, and European satellite services provider have signed a memorandum of cooperation with the goal of introducing a range of innovative global satellite-based surveillance services to the aircraft management industry and broader aviation market. These services will be powered by a specialized constellation of over 100 satellites collecting automatic dependent surveillance broadcast messages from aircraft and transmitting the data back to Earth in real time. Spire will develop the space segment, including system design, building the satellites and payloads, ground control, and data collection. Thales will provision the ground air traffic management system and the service supervision infrastructure. ESSP will manage the certification and the delivery of the service for air traffic surveillance purpose and perform H24 operation and supervision, ensuring the compliance with real-time safety critical requirements imposed to ATC. The partners will also rely on Space Alliance formed by Thales Alenia Space and Telespazio to identify and implement possible synergies, bringing further added value in terms of key enabling technologies, secure network optimization, and sustainable operations and services. Netcracker Technology announced the launch of its digital satellite solution, a blueprint for multi orbit IT that can transform how satellites operators manage, optimize, and monetize their business. With this new solution, operators can get the good service quality at any time. They will deliver a premium digital engagement to their customers and expand their business with any offer to any customer worldwide, according to the company. The digital satellite solution incorporates an operations environment with real time service, inventory and topology, multi domain service orchestration, dynamic SLA management, and AI assurance to ensure optimal service quality across space and terrestrial networks. Skeleton will collaborate with other IPCEI consortium members, including Airbus, BMW, Michelin, Newman and Esser, and Air Products, to develop super battery based energy storage power pack, the hydrogen booster. Skeleton's project aims to reduce the total cost of ownership of hydrogen vehicles and encourage their uptake. Implementing this technology will also reduce the need for critical raw materials and elevate supply chain dependence on materials outside the European Union. Estonian government supports skeleton hydrogen technology development within the framework of the pan-European IPCEI hydrogen program Hy2Move for mobility and transport applications with 18 million euros. In total, 7 EU member states will provide up to 1.4 billion euros in public funding, which is expected to unlock additional 3.3 billion euros in private investments. As part of Hy2Move, 11 companies will undertake and collaborate on 13 projects. Estonia, Germany, France, Spain, Italy, Slovakia, Netherlands are participating in Hy2Move, the fourth hydrogen IPCEI. The program contributes to the EU's target of 90% reduction of emissions from the mobility and transport sectors to become climate neutral by 2050. Dedrone announced the launch of its latest airspace security solution, Dedrones on the Move. This solution expands Dedrone's suite of offering for agile, modular, adaptable, battle-proven counter-drone defense for expeditionary forces deployed in volatile or high-risk environments. The solution is equipped with Dedrone's counter-uncrewed aerial systems, command and control sensor fusion platform for 360-degree drone detection called DroneTracker.ai. Dedrone is implemented across 32 countries and is used by 6 of the G7 nation governments, 829 sites, including 49 airports and 59 stadiums, 15 US federal entities, and 20 non US governments. The company actively provides counter drone solutions for some of the most high profile events and organizations, working with public safety entities to protect over 360 satellites globally. Hughes Network Systems, an EcoStar company, announced that Luna Space Telecommunication, a Saudi Arabia service provider under the Skyband Holding Company, has purchased a Jupiter system gateway as well as 1,200 Hughes Jupiter terminals to transform its VSAT network. Leveraging the latest Jupiter technology, Skyband can provide customers with higher speeds and throughput, reach even more of the kingdom's unserved and underserved areas, and introduced a new mobility offering. Skyband provides the latest satellite network infrastructure through multiple hubs to enable the corporate and government sectors in Saudi Arabia to increase their productivity and help achieve their digital transformation goals. By migrating its existing network to the more efficient Hughes network, Skyband will expand into new government, financial, and oil and gas markets and offer new features such as software defined wide area networking. RTX's small satellite manufacturer and mission service provider Blue Canyon Technologies was selected to build two 12U CubeSat buses for NASA's Pulsar mission, which will study ice clouds that form at high altitudes throughout tropical and subtropical regions. In addition to designing and manufacturing the bus platforms, Blue Canyon will also provide mission operation services. The Pulsar instrument polarized sub-millimeter ice cloud radiometer will observe the full diurnal cycle of high altitude ice clouds to improve climate forecasts and provide climate models with high important insights on how Earth's atmosphere will change in the future. Each spacecraft will be equipped with radiometers that will observe the clouds' daily cycle of ice content through two separate wavelengths in two spectral bands and will fly in orbits separated by 3 to 9 hours. Over time, these two instruments will observe the cloud's daily cycle of ice content. That's all for today. See you tomorrow with more geospatial news.